My name is Emma Heller, and today I'm presenting on Lab 1 for Physics 2. So the goal of this lab was to observe the interaction of charged objects and solve for the excess amount of charge on that object, which in this lab was a piece of tape. So the topics that I covered are electric charge, and in this lab we saw that objects can have electric charge that's either positive, negative, or none, which would be neutral. Like charges repel while unlike charges actually attract. And charges can be transferred between objects by contact. And then the electric force, which acts along a line between two point-like objects, can have its magnitude solved for using Coulomb's law. And then finally, the last topic covered was electric field, which is a region around a charged object, which will exert a force on any other objects in the region that the electric field is acting upon. So in the lab, we set the lab up by having two initially neutral pieces of tape be pulled apart, and then they became charged. So in this lab, I refer to the upper piece of tape as the U tape, and that actually became negatively charged because there's an excess amount of electrons on its surface, while the base tape had a deficiency of electrons because it becomes positively charged when you rip them apart. So in the first part of the lab, I looked at what would happen when two U-tapes were brought close together. Like I predicted, they actually repelled because like charges repel. When I brought the U-tape in close contact with a neutral object, which in my case I used a table, I was surprised to see that the tape was actually attracted to the table. This is likely due to the presence of the electric fields of the tape. When the U-tape was brought in close contact with a pen which was negatively charged, it was actually repelled, which means that the charge on the tape must also be negative. In the next part of my experiment, I was actually able to float a piece of tape over another piece of tape as seen in the diagram here. When A gets close to tape B, the electric force from tape A actually acts on B, and that's what causes it to be like lifted up. And then in this case, the net force is 0, so the electric force equals the gravitational force. You can see that in my free body diagram as well. So knowing the mass of the tape, we can solve for the gravitational force, and then using this and the distance between the tapes, we can actually calculate for the charge on the tape. And I found that the charges on each of the tape were negative 1.59 times 10 to the negative 8 coulombs. And then using this information, we were actually able to find the number of electrons, which was 9.94 times 10 to the 10th. And because the charge was a negative, there must be an excess number of electrons on the tape. So we also were able to find the number of atoms on the tape, and we just did this by solving for the area of the tape, and in the area of the atom. In the area of the atom, we just assumed that all atoms have the same length of 1 times 10 to the negative 10 meters, and we solved for area just using pi r squared. And then we found the number of atoms on the tape to be 1.21 times 10 to the 17th, and the ratio to be 8, the ratio of number of electrons to number of atoms to be 8.21 times 10 to the negative 7th. Here's my coding portion of the lab. I have both tapes represented as point charges. The upper arrow is the force of the electric field on the floating tape, which is due to the lower tape. And then the lower tape is the force of the gravity on the floating tape. So both are equal in magnitude and opposite direction. I then solve for the charge on each tape in my code as seen here, and then I just printed the results. So some assumptions that I had to make for the calculations was that the tape was a point charge, so all the charge was just concentrated at the center of the tape. And then I also had to assume that the U-tape that I used, both of them had about the same amount of charge, which was a reasonable assumption since they were the same material and also approximately the same length. My conclusions was that most objects that we interact with every day are neutral, so they have an equal amount of positive and negative charge. And then electric charge results when electrons move from or to an object due to contact. And the tape in my experiment was negatively charged because it was repelled from the negatively charged pen. And the charge of the tape that I found was negative 1.59 times 10 to the negative 8 coulombs. And this is a reasonable amount because it should be greater than the amount of charge for a single electron.